So our second example is about the second interpretation of derivative as a rate of change. Here, the height of an eraser that's dropped from the top of the CN Tower, this is a tower in Toronto, so the picture of the tower, it's 450 meters high, is h of t, which is 450, minus 4.9 times t squared. This is after t seconds. T seconds after it's dropped. Our job is to find the velocity of the eraser after 5 seconds, and also upon hitting the ground. So if you notice, if obviously I'm not at the top of the CN Tower, but I can still do the same procedure of dropping an eraser. It's going to fall to the floor, and it has a velocity after, if this was at the top of the CN Tower, it would fall for over 5 seconds. After 5 seconds, it would have a velocity, and upon hitting the ground, it also would have another velocity. Our job is to determine both, because both the velocity of the eraser after 5 seconds, that's an instantaneous rate of change. The velocity when the eraser hits the ground, that's also an instantaneous rate of change. So how do we solve this? Well, step one, let's find a formula. For the velocity of the eraser, that means t seconds after it was dropped. Okay, well, we can just plug this in, right, to our formula for derivative. Velocity is the derivative of the height position function. You notice from our first video lecture, this is a limit as h goes to 0 of h of t plus h minus h of t of h. Or actually, let's not get confused. Let's call this S. It still represents height, just because our input, the change in input is represented by h, so we don't get confused. What is S of t plus h? This means you replace the input t with the input t plus h. This is a difference quotient, again, difference in outputs divided by difference in inputs. Here, the difference in input is just h. The difference in output is this whole thing. We can simplify this because 450 minus 450 is 0. negative 4.9 times t plus h squared plus 4.9 times t squared. What is that? That is the negatives cancel, so we're left with 4.9 t squared minus 4.9 t plus h squared all over h. What's 4.9 t squared minus 4.9 t plus, in parentheses, t plus h squared? It is, we can factor up t 4.9, we can FOIL this out, t plus h squared. So we're going to this is just the work we did, just one basic step of algebra. There's another step in algebra we need to simplify this difference quotient so we can plug in h equal to 0. The limit as h goes to 0 of 4.9 t squared minus, in parentheses, t squared plus 2th plus h squared when you expand this, you get t squared, the first term squared, plus 2 times the product of the first and second terms, plus the second term squared. You take this difference, what do we get? We get limit. What cancels? T squareds cancel. What are we left with? We're left with negative 4.9. Everything else is negative. 2th plus h squared. Now we're in a position where we can cancel the factors of h. This factor cancels, this factor cancels. Only one of these factors cancels, so we're left with h is h. So what we're left with here is negative 4.9 times 2t plus h. When h is 0, so I'll write this. This is what we're reduced to. When h is 0, we are left with negative 2t times, just plug in h equals 0. Now we can plug and chug. Limit laws say we can plug and chug what the input goes to, we're good. So we can plug in, when h is 0, we get 2t times 4.9. That's the same as negative 9.8. Okay, so last time we found that the velocity of the eraser, t seconds after it was dropped from the top of the CN tower, was negative 9.8 t meters per second. The height of the eraser is in meters. Its velocity is in meters per second. Same thing when I drop it from my hand here. It accelerates towards the ground, gains speed. Every second, its speed is downward, is negative, but its speed increases, but its velocity is negative, so its velocity decreases. Its velocity after 5 seconds, this is just plugging and chugging. So if this was at the top of the tower, 1, 2, 3, 4, 5, what's its velocity? Its velocity is negative 49 meters per second. That's pretty fast. Now, we also want to find out the velocity when it hits the ground. This is its velocity when it hits the ground, negative 94 meters per second. How do we find that? Well, when does the object hit the ground? We need to solve, that's the height of the eraser, t seconds after it was dropped. initially, it's at the top of the CN tower that is 450 meters above the ground. When it hits the ground, the height is 0. So, same thing here. Hits the ground, height is 0. We need to solve for t. 450 is equal to 450 minus 4.9 t squared is 0. Solve this for t. You add 4.9 t squared to both sides. 4.9 t squared is equal to 450. Okay, now what's the next step? Well, we need to undo multiplication. We divide. 450 over 4.9. What is that number? I don't know the numbers, but you can use this on a calculator. That's approximately, let's say, 9, right? Because 450 over 5 is 90. So 450 over 5 is 9, right? And then, so it's a little bit more than 9. Because this is a little less than 5. Square root of this, okay, it's going to be a little larger than 9, right? Because 9 squared is 81. So, okay. So it takes approximately 9.6 seconds to hit the ground. If I drop it from my hand, right, this isn't that high, it's like 6 feet in my head. 1,000, 2 1,000, so that's like 2 seconds, right? Here, it's falling for 9 seconds. So you plug this back into the formula for the velocity. What do we get? We get negative 9.8 times 9.6. That is negative 94, approximately negative 94 meters per second. That's pretty fast. It's almost 100 meters per second. That's falling pretty fast. That's why if you're at the top building, they usually say if you don't, that's say above a street, don't throw things right from the top of the building. Why not? Why not? It's just an eraser, right? It's not that heavy. It's not going to hurt anyone. Well, because it gains this speed. At that speed, that could hurt someone. So that's why you don't want to throw an eraser from the top or drop an eraser from the top of the CN tower unless you know no one's on the street. So what's important here is the steps we had. So just to summarize, what do we do here? Okay, we have a position function. Our job is to find velocity. Velocity is instantaneous rate of change. We do that by computing the derivative from the formula. Limit h goes to 0 of s of t plus h minus s of t over h. And we plug and chug these 2 times, 5 and 9.6. Now, notice in this case, there were 2 steps. Velocity after 5 seconds. Once we have the formula for v, velocity, or s prime of t, we just plug in 5. Second one, velocity when it hits the ground, we need to find the time first. To find that, we solve an equation, get a time, and then plug it back in. So that's just an important thing to remember. Sometimes it's not going to be as easy as just plugging in the time. Sometimes you might need to solve for the time first, and then